Good morning, class. This is Mrs. Groves. Before I go into our lesson today on section 9.2b, I wanted to give you some updates on my progress and some of my thoughts on how we're going to pursue online learning. I am not familiar with Google Classroom, so that is a new experience for me. Any feedback that you can give me on how to make it better, please either put it as a comment in Google Classroom or send a remind. What I plan on doing is to do YouTube videos for the notes, and I will put those as a non-graded assignment. When you've completed the notes, we're going to use the honor system, just go to the assignment and put turned in. Then what I'm going to have is graded homework assignments or habits of work. And I've got those listed under graded, and I would like you to print out the handouts if necessary, or for the most part, I'm going to be asking you to do bookwork and free response. You can either scan them or you can take pictures of them to turn them in. And then for formative assessments, I'm going to be using AP Classroom. And the goal here is to make sure that you are understanding the concepts and that I understand what you don't understand. Don't worry about grades at this point. I'm not sure how I'm going to be doing the grading. Next week, I will think about that. Right now, I'm trying to get everything in place so that you have all the work so that we don't fall behind and you'll be ready to take the AP exam. As far as the AP exam goes, I'm sure that it will be pushed back, but we're all in a state of we don't know what's going on, so we all have to be flexible. So here, my little picture here is a puzzle, and the class is here and I'm here, and we're going to try to make this work and fit the pieces together. So I am looking for your feedback, your patience, and I would like you to stay on task and just communicate with me. So without any further ado, I am going to move from giving this introduction to the notes that we're going to be covering today, and I'm going to do them in several sections because I want to get them out to you as soon as possible. So please have your handout ready and your calculator, and let's go. So today we are going to be talking about section 9.2b. It's two-sided test of hypothesis and how we compare those to confidence intervals, and our focus is on population proportions, which you know are percents. So we have example 1. Okay. This is Bedford's Law and Fraud. When the accounting firm of AJL and Associates audits a company's financial records for fraud, they often use a test. When the accounting firm AJL and Associates audits a company financial records for fraud, they often use a test based on Bedford's Law. Sorry, I repeated that. Bedford Law states that the distribution of the first digits in many real-life sources of data is not uniform. In fact, when there is no fraud, about 30.1% of the numbers in financial records begin with the digit 1. However, if the proportion of first digits that are 1 is significantly different from 0.301 in a random sample of records, AJL and Associates does much more thorough investigation of the company. Suppose that a random sample of 300 expenses from a company's financial records results in only 68 expenses that begin with the digit 1. Should AJL and Associates do more investigation of this company? I'd like you to pause this video, and I'd like you to try to complete the top part, which includes the test of hypothesis and the conditions on your own. All right. When you're ready to continue, start the video back, and I'm going to go through the answers. So, we always have to define our parameter of interest. P is the true proportion of expenses that begin with 1. We were not given alpha, so we're going to use 0.05. This is one sample. Proportions are always z-tests. So this is a one sample z-test for proportions. The null hypothesis, they believe this is to be true. So this is 0.301. They believe fraud is happening if this number is not true. So this is what is called a two-tailed test. And you can figure that out from the wording because they tell you that it's different from this proportion. They didn't give you whether it was better or worse. So here it's different. Conditions. The random sample was stated independent. That's our 10% condition because we're sampling without replacement. So if we have a sample of 300 expenses, we believe that that is going to be less than 1/10 of all their records. So we believe that this company has financial records of at least 3,000. The normal condition. This is a test of hypothesis. We're calculating a z-score or a z-statistic based on the null hypothesis. So because we're doing that, our proportions are based on our hypothesis. Right? So I think that's pretty self-explanatory. Over here, you do not have to write that. You do have to show both of these conditions for the normal. So now what I'm going to do is I'm going to go on to a different sheet of paper so that I can clearly show you what's happening in this example. All right. So we have a sampling distribution. We took 300 records, so that's our sample size. P hat is equal to 68 divided by 300, right? Which gives us 0.227. And we're going to compare that to P naught, our null hypothesis, which is 0.301. All right, so now always draw your graph. All right, this is based on the null hypothesis. So right here, we always put the center, and here this is the null hypothesis proportion of 0.301. All right. Now, our p-value This is a two-tail test. So our p-value is going to be split between the upper and the lower tails. So we're going to have a p-value here, and we're going to have a p-value here. Now our evidence, our evidence is that our p-hat, all right, our p-hat here is at the lower end. So p-hat is equal to 0.227. All right. So this clearly shows that you understand what you're doing. And again, we're doing a two-tail test. And we want to calculate a z statistic to tell us how far this p-hat, okay, our sample proportion is from the population parameter. So you should be familiar with the formula. And my best way to explain how to remember this formula is think of a z-score. How far is this from the mean? So the formula is going to be z. How far is p-hat from p-naught? And then we have p-naught 1 minus p-naught divided by n. Now, never put that on your test, all right? Because if you make a mistake, they're going to take points off. So you just want to make sure in your mind that you know how to do this. And if you put it on your test and you're not sure that it's correct, then scratch it out before you finish. So now I'm going to show you how to do this problem, okay, with the calculator and calculating all the steps. And then I'm going to show you how to do it with the easy way on your calculator. So this is the long way we're going to do, and then we're going to do it the easy way. So z is equal to 0.227 minus 0.301 divided by, okay, so that is the mean for our null hypothesis, and the mean, the standard error for it is going to be 0.301 divided by, times 0.699 divided by 300. And what I'd like you to do now is pause the video and do that calculation. Okay. So you should have gotten the z value of negative 2.79. Okay, we're going to save this room over here for the calculator work. Okay, so you have this, and you know, based on the empirical rule, that being 2 to 3 standard deviations away from the mean, this area is going to be very small. So if I were to calculate the p-value using normal CDF, and I just want to make sure that you know how to do these commands. So the p-value is equal to the probability that z is less than or equal to negative 2.79. And because this is a two-tailed test, right? This is a two-tailed test, we have to multiply it by 2. So let's just practice that. So you're going to go to your calculator and you're going to go second distrib. You're going to go to normal CDF. Okay, you either put a very small number in there, like negative 99999. The lower bound is your z-value of negative 2.79. This is a standardized score. Hit paste. Okay, and that is the p-value. Okay, that's going to be the p-value right here, which is 0.0026. And since these are symmetric, the p-value over here is going to be 0.0026. So, I think I made this a little smaller to keep everything on here. Okay, so this is going to be equal to 0.0026 times 2. So this is going to be equal to 0.0052. And you should be saying to yourself, that's a small number. What am I going to do? I'm going to reject the null hypothesis. Right? So that's how you do that. So if you use your calculator to do this problem, and you do need to know how to do this because you're going to get multiple choice questions that might ask you, fill this, what is the correct way that this should be set up. All right. So to do this with your handy dandy calculator, okay, you're going to go to Stat. You're going to go to Tests. And this is a one proportion z-test. So that is option 5. You hit enter. Okay. You put in the null hypothesis, which is 0.301. X is the number of successes, which in this case was 68. N is the sample size. And here, this isn't a left tail or a right tail test. This is a two-tail test. So we hit calculate. I'm not sure if you're able to clearly see that. Okay, but what you should be seeing is if you run out of time on your AP exam, you give the z-score. Z is, in this case, negative 2.81. The p-value, and here it's confusing because p is the p-value, is equal to 0.0050. All right? So you must provide this, and you should show all of this work. All right? Now, what I want to make sure that you understand here is that what's happening with alpha? Okay, alpha is divided by 2. So because this is a two-tailed test, alpha over here is equal to 0.025. And if I get a p-value that's less than 0.025, then I'm going to reject. Here, alpha is divided by 2, so that again is 0.025. And if my p-value was on the right-hand side and it was smaller than 0.025, I would reject the null hypothesis there. So I want to make sure that I've covered all my notes here. And I'm going to go back to my completed handout. Please disregard that. All right. So, the conclusion in context. Okay. Since the p-value 0.0052 is less than alpha 0.05, we reject H naught. There is convincing evidence that the proportion of expenses that have the first digit of 1 is not 0.301. So from the company's perspective, therefore, AJL should be doing more investigation of this company's records for fraud. So we've just completed a two-tailed test. Now a two-tailed test, we're now going to do a confidence interval to see how our decisions would be the same or different. So we're going to continue with our Bedford Law and fraud example. It says find and interpret an appropriate confidence interval, keyword is appropriate, for the true proportion of expenses that begin with the digit 1. For the company in the previous example. Use your interval from A to decide whether this company should be investigated for fraud. I think that I need to change that. So, always define the parameter of interest. We are now doing a confidence interval. And we did confidence intervals in Chapter 8, so this should be a review. The test of hypothesis that we did was alpha equals 0.05. So the confidence level to doing a comparable confidence interval is going to be 1 minus alpha. So we are going to do a 95% confidence interval. The test here is not, it's going to be a one sample Z interval for proportions. The conditions, random and independent, are identical to the test of hypothesis. The condition that's different is normal because we're doing a confidence interval. Okay. So we're looking for the sampling distribution for p hat. So here the normal condition for confidence intervals is we're going to take n p hat and n q hat, and we're going to make sure that our successes and failures are greater than 10. So again, I want to make sure that you understand this, so I am going to do this on a separate sheet of paper so I have more room to show you how to do this confidence interval and interpret it compared to a test of hypothesis. All right, so we now know that we are going to do, okay, we're doing a 95% confidence interval. The center here is going to be P hat. And P hat is 0.227, which I haven't shown you how to calculate, but I know you know how to calculate it. So over here, the information that we need is N is 300. P hat is equal to 68 over 300, which is 0.227. And our confidence level is 0.95. And we need to find the critical value, the Z critical value. So just as a review to make sure you know how to do this, this area here, guess what? It's 0.025. And this is 0.025. And you should be making a connection between, okay, before we were doing a test of hypothesis and we were looking at the tails. And the tails were both 0.025. If I want to find the critical value for 95%, well, you do it. We are going to go second distrib. Okay, and we're going to go clear, quit, and we are going to use inverse T, inverse norm. Okay, for a 95% confidence, okay, we look at the area from the left and we put in 0.025. And you should have this one memorized, 1.96. Okay, and when you're writing the critical value, you could put 1.96 because it's assumed it's plus or minus, or you could put plus or minus. Right. So what we want to find is the lower bound, and we want to find the upper bound. Okay, and any of the values that are between here are going to be plausible values for our population parameter. So let's go back, and this will be a good review for confidence intervals. The formula, okay, is going to be P hat plus or minus the critical value, Z star, times the standard error. So that's going to be P hat 1 minus P hat divided by N. So that's the formula that you should be able to understand, okay, for calculating a confidence interval. So P hat 0.0227 plus or minus the critical value, which is 1.96. And then the standard error is going to be 0.227 times 0.773 divided by 300. So I want you to take a moment to make sure that you know how to calculate this number, right? Because that number is going to be the standard error of P hat. Okay, so while you're doing that, I'm just going to write this. Okay. And you should have gotten a number that is 0.0242. This is the standard error. Now I want you to multiply these two numbers and think to yourself, what is that number going to be called? Did you get it? This is the margin of error. Margin of error, again, is how far my upper bound is from my sample statistic and how far it is from my lower bound. So I'm going to get my confidence interval. I am going to, for my lower bound, take this number, subtract it from this number. You should be pausing this if you need to, if you need more time, to make sure you know how to calculate these numbers. Okay, so that should be your lower bound. And your upper bound. Okay, so now you're going to take this number and you're going to add the margin of error. And you should get 0.274. So that is my 95% confidence interval. My lower bound is 0.18 and my upper bound is 0.27. So now, how do you do this on the calculator? This is a review. You are going to go to Stat, Tests. Okay, this is a 1 proportion Z interval, so you have to keep going down. It's a 1 proportion Z interval, which is A. Hit Enter. Okay. Here you put the number of successes, 68. Sample size, 300. The confidence level is 0.95. And you hit Calculate. And you'll notice that is the calculator very different? The calculator gives me 0.179 to 0.274. So it's a little bit of rounding error, not a big deal. So now, we have a confidence interval. And what does that mean? Well, if my lower bound, okay, so my population parameter is someplace in here. Okay, so here's my lower bound, here's my upper bound. Okay, and our null hypothesis was P equals 0.301. So where is 0.301? P equals 0.301. All right? So if P is not in this interval, if it's outside of the interval, we have convincing evidence based on this confidence interval to reject H0. If it had been on the lower end, we would reject H0. And everything in the middle is fail to reject H0. And just our confidence interval captured the true P. Right. So that in case you want to have a picture of that. There you go. That's all the work that we did. I'm going to go back to my completed notes. And the first thing we're going to do is what we've done in the past. Interpret the confidence interval in context of the problem that we were just given. So these are the notes that were on my handout for calculating the confidence interval. Interpreting it, we are 95% confident the true proportion of expenses at this company begins with the digit 1 is between 0.18 and 0.274. So the confidence interval is telling us, have we captured the true P? Well, our P is 0.301. Since 0.301 does not fall in our 95% confidence interval, we have convincing evidence to reject H0 at alpha equals 0.05. So a 95% confidence level translates into alpha of 0.05. If I had a 99% confidence level, that would translate into alpha of 0.01. So, is 0.301 in our interval? No. Right? It's not a plausible population parameter giving us convincing evidence to reject the null hypothesis. So, in conclusion, what are the differences between a two-tail versus a confidence interval? Well, notice in the example that we just did, a two-tail test of hypothesis and confidence interval gave us the same decision. Okay? Gave us the same decision. Okay? And probably should put confidence level is equal to 1 minus alpha. A two-tail test, it's important to know that it's a two-tail test of hypothesis and confidence interval give us the same decision. And in fact, the confidence interval gives us more information since it provides all the plausible values for the population parameter. So, there is the comparison of a test of hypothesis with the confidence interval. I will create a new video with the rest of the examples in this handout and post that as soon as I can. Have a good day. Stay safe and healthy. Mrs. Groves.